Great, thank you, Titus. And it's a pleasure to be here and to be part of Microbit Live, the second edition. Gavin and I are going to talk to you about this really amazing color display called the Sparklet from Microbit. You see a picture of it here. I'll give you a quick overview first of what you're going to learn in this session. We have 4 parts. Gavin will start off telling you about what is the Sparklet for the Microbit, and it's currently just become available. I'll then dive into programming the Sparklet with MakeCode, show you how to do that. Gavin will come back and tell you about how to create art and animations with an application called Expressive Pixels that he developed. And then I'm going to show you how to take the Expressive Pixel animations and import them into MakeCode to use them with the Sparklet. So with that, I'm going to turn it over to Gavin, and we have a slide here for him.
Yeah, thank you, Tom. Hi, everyone, and thanks for attending our session. So yeah, the Sparklet for Microbit. I felt that, the Microbit kind of was lacking an ability to really express itself, as it were. When I was working on another project, which is Expressive Pixels, where I really wanted to seed the market with a very capable, high-resolution device, with fantastic, color resolution capabilities, but was accessible within reach of the typical, high schooler, maker, that kind of thing. So kind of try to fill that slot there, that gap. So what the Sparklet is, it's a 256 LED 16 by 60 matrix, which is kind of the sweet spot for animations. There's just enough resolution of that to show the typical emoji or 8-bit character. I wanted it to obviously be nicely integrated with the Microbit, so the edge connectors on the rear. It's fully self-contained, so obviously powering these LEDs requires 5 volts, they're 5-volt components. So how would I get this to work with a LiPo? So it has an integrated booster and obviously also charger, 1000 milliamp hour battery, so that will last you a good solid 3 hours of use. And obviously if you're just using it intermittently, then you kind of double and triple that kind of usage timeline. It's in a nice tough polycarbonate enclosure, and the true makers can actually pop it out, and I've exposed all of the pin pads so you can kind of integrate it into other scenarios. And it also has a diffuser on it too, so LEDs are kind of harsh to the naked eye. So I integrated a diffuser into the system too. And so, yeah, so the whole point was, to make it accessible to makers and kids, that kind of thing. So, I've literally selling this at cost with a little bit of extra overhead on top, just for, being able to survive a business and get it into Amazon and pay all those kind of fees. And so my model for distribution is to, because I'm selling it pretty much at cost, is to get, there's no opportunity for resellers to make margins. So that's why I'm going directly to Amazon, so I can avoid all of that stuff. So you can learn more by going to the URL there, and Tom has been an incredible partner to help me get all this ready in terms of MakeCode integration and all of that stuff. So Tom, I'll hand it back to you.
Oh, just one more slide for you, Gavin, if you wanted to go over.
There we go. So I spoke to some of this stuff. So it's using the latest, a very new component, which is a 2mm square WS2812 addressable LED, which is a NeoPixel essentially. So the 16 million colors, very, great color reproduction. Said that LiPo battery, integrated USB charger, and it comes with its own USB cable. Woohoo!
Okay, super. Thanks, Gavin. I'm going to stop sharing for just a second and show you it here. So this is a Microbit Classic V1. This is the Sparklet. There's the edge connector on the back, and you can see the very large LiPo battery, all enclosed in this case. And you can charge it via USB. And I'm just going to plug it in. I've got one of the emojis playing there. Okay, and I've turned the lights way down on that And so that's the basic thing. You just plug it in, and whatever your microbits got on it is going to play. But yeah, I'll show you how we can.
So cameras are very hard to things to capture what LEDs truly look like. So when you see this with the human eye, it's a vastly different experience. The colors are really vibrant.
So I'm gonna just pop back to the slide for a second. So now, so now I'm going to show you how to take that device and just program it with MakeCode for the microbit using the standard NeoPixel driver, the extension that we have. And I did want to run just a little poll here to see how many people are familiar or have used the NeoPixel extension. So I'm launching the poll. The question is, have you used MakeCode's NeoPixel extension? So if you could please answer that. That just helps me to know how many people out there are using that. While that's poll's going on, I'm gonna bring up our favorite editor from the Microsoft team that we've been working on for years now, MakeCode. And I'm going to just start a new project, demo Sparklet. Okay. All right. And so if you haven't worked with the NeoPixels before, you have to add that ability into a MakeCode through the extension menu. And NeoPixels are very popular. They're actually one of the top extensions that get used. So I'm gonna click it here. And I'm going to add it in. Also, I'm going to be using Web USB over to program the microbit. So I'm going to plug in my microbit to my machine, and I'm going to also just plug it into the Sparklet. So maybe you can see that there. Okay. Oh, the poll. So let's see. I'm going to say yes. I'm going to submit my answer. I'm going to end the poll. So according to the poll, we have 14 people said yes and 15 no. So about half and half. Okay. So when I added the NeoPixel extension, you'll see I get this NeoPixel in the toolbar. And what we're going to do is just a very simple program. We're going to bring out the strip lock. So this is basically saying I have a NeoPixel strip. It's connected to pin P0. NeoPixels are driven by data, 3 volts and ground. So it's a 3-wire protocol. But with the Expressive Pixel, we have 256 LEDs. So I'm going to pop that in there. And then I'm going to have to do a few other things to initialize. So I'm going to with the display, because the display can eat a lot of power, Gavin has created it in such a way that it's off initially. So to turn on the display on the Sparklet, we have to write digital 1 to pin 1. And now what we're going to do is just very, very, very simple. We're just going to turn on all the LEDs. So we're going to show, we're going to write and show the color. Let's show the color, some darker color, maybe purple. I like purple. So we're going to show that. And also, because the NeoPixels are so bright, we're going to turn the brightness down. And we'll do that first. So I turn the brightness down all the way to 10. 256, 255 is the top, and it's really, really bright. So I'm going to turn it down to 10. And then we also need to actually give it a show command. Okay. So what we're seeing over here on the right-hand side is a simulation of the NeoPixel. It looks more pink to me. I'm going to try something. What about violet? Let's try violet. Yeah, it's a little darker. Okay. So now what we want to do is we want to actually put this on the device. And so in the lower left-hand corner, you can see my download button has the little USB connection. It's already connected there. So I'm just going to download it. It's going to download directly onto onto the microbit, which is plugged into my Sparklet. And if everything works here, then in a little bit after the copy command, we should see Violet on the Sparklet. The first flash takes a little while. After that, it'll be faster. Okay, still copying. Okay, can everybody see that? Purple. Well, okay.
Yeah.
Maybe it doesn't look purple to you. Okay, so we've lit up. So with this little program, and let me zoom that in a little bit for you to see better. So with this little program, we've just lit up all the NeoPixels, but it's a matrix. So what we really want to do is be able to write XY positions to the matrix. In order to do that, there's a little known feature of the NeoPixel package called set matrix width. And so what this lets us do is tell the extension, how many pixels there are in a row. And so we're going to put 16 in there. And then with that, we can write a loop. Let's write a loop. And we're going to put that loop from 0 to 15. And Gavin, I'll let you check the chat to see if you get any you get any questions there. We're going to go to 0 to 15, and we're going to use another thing that's in the advanced part of the NeoPixel, which is to set the matrix color at a position. So there's essentially this helper function that once you set the width, it now knows how to set an XY coordinate. And so we're going to basically just create a diagonal line, and red on purple is not really good, right? What do we want to put over purple? Maybe we'll just do white. That'll be brighter. Okay, so now we're going to and actually to make sure that white line is sort of a little brighter, I'm actually going to use some math. And what am I going to do? I'm going to make the line a little wider. So I'm going to add 1, and I'm going to put the index there. So now if we and now we have to actually do another show command, because all we've done now is just write to the display. Okay, and now if we go over and see the linear NeoPixel, we see sort of, oh, there are these white spots. Maybe they're not that white; they're sort of gray. So maybe I'm going to use a different color. Actually, why don't I just make it black? Maybe that's better. Okay. Oh, black is about the same. Interesting. Okay. How about yellow? I should choose something else better. There we go. Yellow pops out a little bit more. But you see, we don't really see the diagonal line because it's linear. But let me at least download it and see what it looks like, on here. And I'm going to stop sharing for a second so we can actually see it. And if I get it close, can everybody see the diagonal line? Yay! So we have a diagonal line. Okay. So that's just a little bit about programming. But the great thing about the microbit is that you can do the programming in the web browser and sort of see your results without having to go to the device. And so one of the things that really gets me is that this linear strip is not the greatest. So what I'm going to do is I'm going to take the program here, and I'm going to go over to a different version of the editor that I've created. And this editor just has a feature that lets me display the matrix directly in the simulator. And this will be coming eventually to the microbit, to the make. Right now it's on a local thing. So I'm going to just paste the same program in here and immediately see a little problem. I've forgotten to add the NeoPixel extension here. So let me add the extension. There it is. And all those errors should go away. Right. And now there's a little extra call that I need to do to tell the simulator to set the matrix width at the device that's on digital pin P0. And I want to tell it it's got a width of 16. Okay, so now when I do that, ta-da, we see the matrix actually appear in the simulator. If I go full screen, yeah, you can see that. So with this modification to the microbit simulator, we'll be able any matrix display like the Sparklet will be able to actually prototype and play there directly on that. But this is right now a preview. This feature is not available, so we hope to make it available primarily via the extension. Okay. Of course, the Sparklet is great for doing graphics and displaying the graphics, but we want to take advantage of the fact that the microbit has buttons, and we want to be able to create things like games. So what I've done in this URL here is create a little project that lets us play games using the Sparklet. And I'm going to run a little video here just to show you. I'll talk over that while it's going. So here I've programmed it with two popular retro games. And you'll see here, there's a splash screen. There's a microbit on the back. The splash screen shows two different games that are available. And when you press the A button or either button, when one of the games is there, it starts. So here is the first game. It's the snake game. And you can see I'm playing the game with one hand. I'm using the A button to rotate the snake counterclockwise and the B button to rotate the snake clockwise. And the little red dots are the apples that the snake is trying to eat. And when the snake eats the apples, then it grows. And if you run into the wall, it's game over. Okay, so that's the first game, just the snake game. And the snake goes faster over time. It grows larger. The second game is a popular game that you know from Russia with Love, I believe, where the blocks fall down. This one is interesting because you need to move the blocks left and right. You do that with A and B buttons. To rotate the blocks, you press the A and B button at the same time. And to make the block fall all the way down really fast, you shake it. So here I'm using like all the functions of the microbit to implement it. So it's really fun. It's really fun to write games. Oh, and yeah, we don't want to look at that, I guess. It's really fun to write games using the Sparklet and the microbit because you're really a bit challenged with 16 by 16, as well as just two buttons and an accelerometer. But you can do quite a bit, as you can see there. So what I want to show you now is how we load that game up. And if you haven't seen this before, it's pretty nice. If you have a project, you can export it to GitHub. And what I'm going to do is use the import feature here. If you haven't seen this, the import is on the right-hand side. So I'm going to import the URL that I just gave you, and that's available in the description of the talk. I'm going to import this microbit project directly into the editor. Okay, and so what you'll see here, not surprisingly, is the game, right? If I do there's the snake. There are the blocks, and you know, if I do this, now I'm playing the snake game in the simulator, right? So again, with the addition of the matrix in the simulator, then we can actually debug. And I'm not going to go through the code here, except to say that I created a little screen abstraction. This should look very familiar. It creates a NeoPixel strip. It sets the brightness. It sets the matrix width. It's essentially my screen abstraction for the games. I have one global screen, and then I have two games here, the snake game, and these games are just written using basic logic, a basic game loop with event handlers, and a display routine. And the display routine is not very surprising. It uses the screen abstraction to just set the pixels. So it's really simple. And here, actually, you're seeing we're using object orientation. So, you know, with something like the Sparklet and the microbit, you can go write little games, and it's a lot of fun. So, and also very playable. The other thing here, I'll download the game.
Hey Tom, so we have about 4 minutes left.
Oh my God, we have 4 minutes left in the whole thing. Oh my gosh, thank you. Okay, then we have to stop doing this. I'm going to turn it over to Gavin.
So Tiffany had a good question about, she would love to know how we can create emoji animations. Well, as
yes, okay, thank you, Gavin, because I have the ability to go on and on here. So let us. So
I'm going to show you that.
And you're gonna share screen. So how do we create pixel art?
Yeah. So now my share screen button isn't working.
Okay. Now you.
No, there we go. Oh, okay. I've got to. Now I can do it. All right. So everyone had that question about, well, how do I create real animation? So can everyone see that? Can you say yes, Tom? All right. So Expressive Pixels, I created. It was originally for the accessibility community, but then we went crazy and created it for makers. So Expressive Pixels basically is a very 8-bit retro way of anybody of any ability to create animations. And essentially, basically it's a very glorified GIF editor where you have your frames on the bottom and you can really easily create animations. And if I want to create, we have, full emoji integration where you can integrate emojis and then you can, start drawing. Obviously, you have, the traditional cut and paste. And so if I wanted to create an animation of, as I say, a rocket ship flying through space or taking off, that's exactly what I did with this. I took the rocket animation from the emoji gallery, which is transportation or something like that. And then essentially what you do, I shouldn't have clicked that, now it's downloading the darn emojis. So you basically take the frame and then you can say, I want to move it 1 pixel to the right, and then you can say copy frame to the right. And so essentially you can create very easy animations to successively create an animation. And so how do you integrate, this animation gallery into a MakeCode application? One of the things we do have a whole cloud gallery too, where you can upload and share with other makers as well. So here's our animation gallery in the cloud, anyone can share to. And if I want to export this so that it's MakeCode consumable, you click on the ellipsis there and copy programmable MakeCode string to the clipboard, and then you can just pop it in there. And so, Tom, do you want to? I'll give that control back to you. And
yeah, thank you, and I will do this much faster now. Thank you, Gavin.
Yeah, and so Tiffany, this is available on the Microsoft Store. Just type in Expressive Pixels, and you can download it for free and create. And you don't necessarily have to have a device either.
Can you see my screen now?
Yeah.
Okay, so what I'm going to do is I'm going to take the rocket journey, and if I go over here and I go to the ellipses, it has copy programmable MakeCode binary declaration to clipboard. Okay. What we've done, and I have to, when I do this, I have to make sure it's 16 by 16 because that's my Sparklet. So it's going to crop it a little. And now what you'll see over here is we've been developing a new extension for the Expressive Pixel. And really what this does is allow us to, it understands the animation format that Gavin uses, and it allows us to play the animation. So currently you can see, if it's running, you can see the emoji I just did last, which is the laughing one. And what I'm going to do is go to JavaScript here, and I'm just going to remove the animation of the laughing face, and I'm going to paste in the thing I just copied, right, which is the rocket. And now, boom. Okay, let's make that full screen. Okay, and let's reset that. Okay, and there goes. I don't know how well you can see that. There goes the rocket ship on the parachute. Oh, it's a long animation. Yeah. Okay. So essentially, what happens here is the code you've seen before. We create a NeoPixel strip. We set the width. And we copy over this animation. But we need to use an extra extension called the EPX display, and that's available as well now. And what that lets us do is interpret the string we get from Gavin. So again, it's a simple download. I'm going to do this as the final part of the talk. It's a simple download. Oh, compilation failed. That's not good. So maybe we're not going to get that this time. we're going to, I think we're going to stop at that point, so I have a little bug or something. But we do have an extension there that we've developed with Gavin to display the animation, so you can import it from there. Okay, so I have one more poll, Titus, if that's okay to run.
Yeah, throw the poll up, and then as you're launching that, maybe Tom and Gavin, if the chat's been quite active, if they're
yeah, super. So I'm gonna do that. Right, I'm going to do that, and I'm going to launch the poll, and then I think maybe I have one more slide. Let's see. There's that. Yes. So so here's the URL. I'm sorry. Here's the URL for the package that lets you take the Expressive Pixel animation and use it in MakeCode. And again, all these links are available in the description of the talk, and we will make the talk slides available as well. So there's the poll, and then our final slide. So questions in the chat.
Yeah, I think we've been answering those.
Yep.
Yeah, so depending on demand, so right now it's available on Amazon US, and if the demand is great, then I will go to all of the lengths of getting VAT codes and all of that, subscription fees to get the tax man to collect tax, and I'll make it available on Amazon.uk. So let us know somehow if you think this is definitely something that makers and kids and so on are going to have fun with. Definitely want to make it available. And as I said, I'm selling these essentially at cost with a little bit over, just to cover business expenses, just to make it accessible, because it is pretty advanced device. A lot of componentry on there, so definitely want to price this within the range of everyone without losing money, obviously. But
wonderful. Well, thank you again, both. This is, I think, we probably could have taken an hour or more, and there's so many more ideas. So we'll have to have you back to tap you on the shoulder again. Thanks for sharing the links. I know that there's probably going to be dozens of projects coming out, probably even as soon as this afternoon from our attendees. So thank you again.
Yeah. And let us know if you have questions. Please feel free to contact us.
Yep.
We're readily available LinkedIn. I'm T-Ball, TBALL at Microsoft.com.
Yeah, likewise, Gavin Jancke, only one of those. You can find me easily.
Okay, thanks everybody.
Yeah, thank you.